So in this class, we're going to discuss reliable data transfer over lossy channel with IT errors, RDT 3.0. So reliable data transfer 3.0 and pipeline reliable data transfer protocols. So in that pipeline data transfer protocols, we're going to discuss go back and selective repeat protocols. So RDT 3.1 is a channel with errors and loss. So new assumptions underlying this channel and can also lose the packets, data or acknowledgement. So as and when lose the packets, so either data or acknowledgement. So what is exactly the channels with errors and loss? How do you handle in this protocol? That is a 3.0. So checksum and sequence numbers and retransmit will be so helpful, but not enough. So how do we can as a channel with the errors and the packet losses occurs. If it is an error in the packet, so error in the our packet itself is lost, how do you handle? So what is this approach? 3.0 approach says that sends and waits reasonable amount of time. So for acknowledgement, so it is sender has to wait some amount of time. So reasonably retransmit the same packet. So till acknowledgement is received. If it is no acknowledgement received in this time also, if the packet or acknowledgement just delayed. So suppose sometime it is a lost the packet, sometime acknowledgement may not be arrived. At that time, retransmission will be a duplicate, but sequence number already it is handle this duplicate so handling of packets handled by the sequence number. So even receiver must specify the sequence number of the packet being acknowledgement. So even receiver also tells say this sequence number has to receive already. Requires countdown timers in the case of RDT 3.0. Here, this is a FSM, so RDT 3.0, there is a 4-state wait from Colabo as I explained in the already. So this is RDT send data, send the MAC packet, UDT send data, and start timer in case of, so that is a FSM state 1 and state 2 wait for acknowledgement. So that is a positive acknowledgement 0. So it is a received packet, corrupted received packet, it is a checks the condition. So that is a timeout. If it is a timeout, UDT start timer, it is standing. So again call from this. So this is exactly so how. So if one state to another state is moving. So again, so this is a wait acknowledgement. So receives the packet not corrupted. If it is a corrupted packet, this is exactly the events. If it is a not corrupted and acknowledgement packet is stop the timer. It is start timer and stop timer. Wait for call from above. So again receives the packet. So send the packet to the data checksum and send the packet. Wait for acknowledgement 1. So at least wait start timer. It is a wait it is a corrupted. So it is a not corrupted. It is exactly wait for acknowledgement. So this is FSM and 4-state. So it is a very simple protocol RDT 3 in action. Sender it is a packet is so send the packets 0. So packet 0 receives the packets 0. Receiver it is send acknowledgement back to the sender. Receiver acknowledgement 0 is received here. Send the packet 1. Packet 1 receives the packet by the receiver and send the packet acknowledgement back to the sender. Acknowledgement 1 is received by the sender. Again send packet 0. So again it is a receives the packet 0. Send acknowledgement. So here it is a no loss. That is a packet is a no loss. Here so packet loss. How packet loss? Send packet 0. So receives the packet 0. So send the acknowledgement back to the sender. So again receives the acknowledgement. So again send the second packet. Second packet means packet 1. Packet 1 is so that is a lost in between. So sometimes so packet is a timeout. So resend that again packet 1. Same packet has been, you see that same packet has been reset. This is the packet. Again acknowledgement received by the from the receiver back to the sender. Receives the acknowledgement, send packet 0. So this is receives the packet 0. So again acknowledgement so back to the so that is a sender. So acknowledgement has been sent by the so receiver back to the sender. This is a no packet loss. So this is the packet losses occurs. Resend the same packet. So the retransmission of the same packet in case of RDT 3.0. So in RDT 3.0, you see that this is another suppose if it is acknowledgement is lost. So scenario is given, send the packet 0, receives the packet 0, acknowledgement back to so packet 0, acknowledgement 0 has been received by the receiver So back, so receiver, from the receiver back to the sender, send packet 1. So that is receives the packet 1, send acknowledgement. Acknowledgement itself is lost. So certain timeout period is occurs, start timer, timeout period is occurs. Again resend the packet 1. So again detect the duplicate packet, send acknowledgement 1 back to the sender. Again is a packet 0, this is the packet 0, send acknowledgement 0. So this is exactly acknowledgement. So again packet 0 it is sending, yes, already packet 0 is contained, but it is transmitting the, so that is acknowledgement. You see that acknowledgement 0 has been, so as and when acknowledgement loss is occurs, it transmit the which acknowledgement has been lost. So that is exactly retransmitted, detect the duplicate, and it is a sends. So this is acknowledgement loss. Premature timeout or delayed. Suppose if it is a packet 0 is received, so it is a, again receives the acknowledgement, send the packet 1. So again it is a timeout period here. So it is a premature. Premature is, so before only it is a timeout. So you see that, so it is a, so it is a wait till send the acknowledgement, but premature itself resend the packet 1. Again it is a packet 0 is resend. So it is a, again, so detect the duplicate packet, this is the acknowledgement. So like that, two packet acknowledgement will be received, two packet, one packet 0. So like that acknowledgement 0, and so this is a premature. Suppose it resend, so it is a premature means, so earlier itself is timeout or delayed some acknowledgement. So this is the, so delayed acknowledgement scenarios are explained here. So performance of RDT 3.0 is a correct, but performance things. So 1 Gbps uplinks, 15 Mbps propagation delay, and 8,000 bits of packets. So this is a transmission delay is so length of the packet and divided by R. So 8 to the 8, it is already given 8,000 bits. 10 to the power of rate of transfer, it is 10 to the power of 9 bits per second. So 8 microsecond it is a transmission delay is occurs. So sender so utilization so factors. So this is the equation. L is the length of the packet, and R is the rate of transfer, and R round trip time, and L divided by R length of the packet divided by rate of transmission. So 0.00 microns. So that is a 30.08. It is already given. So it is a 0.0027. So RTT is 30 seconds. So 1 KB of the packet is every 30 seconds. 33 kbp seconds throughput over the 1 Gbps links. Network protocol limits over the physical resources. So this is exactly how first packet is transmitted. So the packet is transmitted. This is the first packet is received, last packet is arrives and sends that back by the acknowledgement. So this is also it is written in case of one round trip time. Complete one packet is at the sender time. So the first packet is transmitted at time 0. So how exactly complete round trip time? It is a acknowledgement receives and as a second next packet. So it is a packet is a T is equal to round trip time plus so L length of the packet divided by so rate of transmission. So user sender of so that is a utilization so factor has been defined. So this is the way, this is the way. So this is the value 0.0027 will be get back. So normally pipeline protocols are nothing but there are two protocols to back N. So and also there is a so one more protocol is also available. I'll explain you. This is a very interesting protocols. So go back N and selective repeat as the two protocols in pipeline protocols. Pipelining sender allows that. So in earlier cases, what we have discussed so far, so only one packet sending, and then so for the packet 0, so acknowledgement 0 will be received back to that. So that is a so receiver back to the sender. So here sender allows the multiple in flight yet to be acknowledged packets. So instead of sending one packet at a time, so 2 packet, 3 packet, 4 packet at a time you have to send depending upon the window size. So ranges of sequence number must be increased and the buffering at the sender and receiver. So being done. So in case of pipeline protocol, so the data pack earlier, so RDT 1.0, 1.2.0, 2.2, and 3.0 data packet sent is one has to receive by the receiver. Again, one acknowledgement will be sent back to that. So receiver is the server here, back to the desktop machine. So here it is you see the pipeline protocol. So 4 packet at a time, 3 packet at a time, again 3 packet at a time. So like that sending. Receiver it is a server will send so corresponding acknowledgement back to that. So senders. So two generic forms of pipeline protocol. One is go packet protocol and selective repeat protocol. So here pipelining increase the utilization time, first packet to be transmitted and last packet to be transmitted again. So the 3 packet at a time. The first packet arrives, last packet arrives, second packet also arrives, and third packet is also arrives, and 3 acknowledgement will be received back to that. So it is a T RTT into L by R. So your sender utilization factor is just changes in case of pipeline protocol 3L divided by data transfer on complete round turn divided by L by R. So again it is a changes. 3 packet pipeline increases utilization by factor of 0.3. So that is exactly 0.0081 microns. So pipeline protocols overview consent. Go back one sender have up to n acknowledgement packet in a pipeline receiver only sends the cumulative acknowledgement, does not acknowledge the packet if there is a gap. Sender has a timers and oldest unacknowledged packet. When the timer expires, retransmit all unacknowledged packet in case of go back and protocol. So that is whichever the packet is not received the positive acknowledgement. So that packet unacknowledged packet only retransmit by the go back and in selective repeat, sender has to up to n packet will be sent by the sender in case of pipeline protocol like selective repeat. So receiver sends so individual acknowledgement back to the each of the packet to back to the sender. Sender maintains the timers. So if the within the timer it is not received so each of the unacknowledged packet, select the particular packet. When timer occurred, retransmit the only the unacknowledged packet. That is what we call as selective. As the name itself is, whichever the packet is not received, only that packet will be selected. It retransmit that in case of pipeline so protocols. So in this class, we have discussed about reliable data transfer over lossy channel with its errors of RET 3.0 and pipeline reliable data transfer protocols. So and overview of go back in protocols and selective repeat protocols.